Hey guys, this is Mrs. Foy, and this is a tutorial on all of the nomenclature that we have learned so far in chemistry. So at this point, we're talking about ionic, acid nomenclature, and covalent nomenclature. So this is just kind of a little poster that kind of shows you everything that we've learned so far. So the very first nomenclature that you learned was about ionic nomenclature. Ionic nomenclature, you're always going to see a metal and a nonmetal. Remember that metals like to form positive ions. We call those cations. They tend to lose electrons. And nonmetals, which we call anions, tend to gain electrons. And so these are the ionic nomenclature rules. These are actually the hardest rules, which is why we taught you these first. And these positive and negative ions form ionic bonds, and that forms something called a crystal lattice. They don't form molecules. We actually call one particle, so to speak, it's actually the ratio of the positive to the negatives, but don't worry about that right now. We actually call those particles a formula unit, technically speaking. So we have three basic types of ionic nomenclature. We have binary ionic. This means two ions in the formula, so you can see all of these have two. Here I have a positive and negative, a sodium chloride, calcium phosphide. Calcium is a +2. We know this from the column it is in the periodic table, and phosphide is a -3. And so we balance the charges to make that neutral. We also learned about transition metals, and transition metals are those metals in the short columns of the periodic table that can form variable charges. So lead can sometimes form a +2 charge, a +4 or 5, sometimes, a +4 charge, sometimes a +5 charge. And so we have to use Roman numerals to tell us the charge of that particular ion. So here I know that oxide, and by the way, all of these end in ide, I-D-E. We add that ide to the negative anion. So this is oxide, and I know that that has a -2 charge, and so there's only one lead there, and so the lead must have a +2 charge, and so that's why I know this is lead 2 oxide. And then we taught you about polyatomic ions, and in our class you had to memorize about 12 of them, and nitrate was one of them, NO3-1. This is sodium nitrate. And then we taught you that if you have one oxygen less, we change that 8 to an ite, and that's sodium nitrite. Acid nomenclature is basically pretty easy. An acid, the definition that we use in our class, is that it is a compound that gives off a hydrogen proton in water. So technically speaking, we usually see this parentheses AQ here that means that it's dissolved in water. So we have binary acids. Binary means 2, so there are 2 different atoms in the compound, and oxyacids, which are acids that have oxygen in them, in this case polyatomic ions, as we'll see. And so hydrogen is always +1. So this is hydrochloric acid. In binary acids, we always use the prefix hydro. So this is hydrochloric acid, and this is hydronitric acid. And there is a 3 here, right here on the hydrogen, because remember, nitride is a -3 ion, and so I have to have three hydrogens to balance out that -3 on the nitrogen. So anything that has H and one other element, guys, is always hydro. Hydro, whatever, ic acid. Oxyacids are going to be the name of the polyatomic ion, no hydro. And if the polyatomic ion is an 8, we make it an ic, ending in the acid. If the polyatomic ion is an ite, we put an us, O-U-S, on the end. So I see that that is nitrate, and so this means this HNO3 in water is nitric acid. HNO2, this is going to be nitrite, because it's one less oxygen than 8, which I see over here in my polyatomic rules. So this is going to be nitrous acid. Oxyacids never have a hydro. You just have to know the name of the polyatomic ion. If it ends in 8, it's an ic. If it ends in ite, it's an us. And then the very easiest nomenclature we save till last. That's covalent nomenclature. So this is going to be two nonmetals, a nonmetal and a nonmetal. And there's going to be no stealing of electrons here. These are not ionic bonds. These are going to be shared electrons, which are going to make covalent bonds. And we call these particles molecules. And we have very simple nomenclature. You just have to know your mono, di, tri, tetra, penta prefixes. So this is carbon dioxide. Everybody knows this is carbon dioxide. And most people know this is carbon monoxide. This is water, but the correct name for it is dihydrogen monoxide. And this is carbon tetrachloride. So let's practice some of these and see how you guys do with this. So let's see, I'm going to need to get my pen here. Okay, here we go. Hopefully you can still see this, all right? So MgS, I see that's a regular metal. That's the first thing I'm going to look at. Is that a metal? If it's a metal, then I'm going to use just basic ionic nomenclature here. So that's just going to be magnesium sulfide, okay? So it's going to end in IDE, magnesium sulfide. Potassium nitride. Well, I know potassium is a +1 charge. Nitride is a -3 charge. And so potassium, I'm going to need 3 of those to balance out the -3 on the nitride. Sodium hydroxide. Sodium is a +1. Hydroxide is a polyatomic ion, OH-. And so I just need one of these and one of these. So this is going to be sodium hydroxide. Sodium hydroxide. I don't need a parentheses around the polyatomic ion. I only need that if I have more than one polyatomic ion. So for example, if I made this calcium hydroxide, calcium has a +2 charge, and so I'm going to need 2 hydroxides. So here I would use a parentheses around my polyatomic ion and a subscript 2 that means I need 2 of them. This here is a metal and a nonmetal, and this is a transition metal. This is lead. So I need to use a Roman numeral for this. Well, oxide I know is a -2 charge, and I have 2 of them. And I have 1 lead, and therefore the charge on the lead must be +4. And so this is lead 4 oxide. Lead 4 oxide. Awesome. Barium nitrate. Well, barium is a +2 charge, and nitrate is a polyatomic, NO3-. And so this is going to be an example of when I need a parentheses because I have a polyatomic ion and I need more than one of them. Barium nitrate. This is copper carbonate. Copper is a transition metal, so I need to figure out the charge. Well, I know that carbonate has a -2 charge, and there is 1 copper there. So this must be copper 2 carbonate. Copper 2 carbonate. Copper 2 carbonate. Here, this is an easy one. This is calcium. Calcium is not a transition metal, so I don't need a Roman numeral. And so this is calcium, but CO2 is carbonite. And so this is calcium carbonite. Remember, 1 less oxygen than the 8 is the ite. All right, let's take a look at some of these acids. The 2 most famous acids are probably these 2 right here, HCl and H2SO4. This is hydrochloric acid, a binary acid, hydrochloric acid. If you did not see the AQ on here, then you would be correct in saying that this was hydrogen chloride. But because it has this AQ, we know it's an acid, and we call it hydrochloric acid because it's going to break apart, dissociate, and give off an H plus in a water solution. This is sulfuric acid. No hydro. It is an oxyacid. So this is sulfuric acid because this is sulfate, and so that makes it ic, sulfuric acid. Hydroiodic acid. Well, I know it's going to be H and one other thing. This is going to be I. I know the charge on I is -1 and H is +1, so I would just write HI with a little AQ to be correct. Chloric acid. Chloric comes from chlorate, and chlorate you memorized is ClO3 -1, and so I'm going to need one hydrogen on there, and so I would write HClO3 AQ. Chlorous acid, that comes from chlorite, which is one less oxygen than chlorate, and so this would be HClO2 AQ. This one is just a simple, let me roll this down just a little bit in case my picture is blocking this. H2S is going to be a binary acid, so this is going to be hydrosulfuric acid, and this one is an oxyacid. You should recognize this is acetate, so this is just acetic acid. Awesome. All right, what do we got here? Oh, we've got some, I can tell this is covalent nomenclature because I've got two nonmetals. This is easy as pie. So I just say the name of the first nonmetal there, phosphorus, and then I use my prefixes, tetrachloride, all these end in "ide." Here, if I have two of the first nonmetal, then I would use the prefix dinitrogen, and this would be tetraoxide. All right, so I think my last page here, I've just got some that I've mixed up a little bit. Yep, so let's see if we can figure these out. All right, so you look at this and you see, yep, that's a metal and a nonmetal. So this is just plain old lithium sulfide. I don't need a Roman numeral because it's not a transition metal. This one is silver nitrate. Silver is technically a transition metal, but that's one of the transition metals that you memorize that you don't need a Roman numeral because silver is always +1. So we just say this is silver nitrate. Silver nitrate. Zinc oxide. Zinc, I know, is a +2. It is a transition metal, but zinc is always a +2, and oxide is a -2. So zinc oxide is just ZNO. This carbon is a nonmetal. Bromine is a nonmetal. So this is going to be covalent nomenclature. Carbon, tetrabromide. So those covalent nomenclatures also end in "ide." Mercury 2 nitrate, well, that's telling me that the charge on the mercury is a +2. Nitrate is NO3 minus, so I'm going to need a parentheses around my nitrate. So it's going to be H2 parentheses NO3 2, that's mercury 2 nitrate. H3P, okay, so technically speaking, I would call this hydrogen phosphide, all right? But if I put an AQ here, then that would be hydrophosphoric acid, okay? Because that AQ means it's in water, and then I know when it's in water, it's going to give off an H+. All right? And then our last one, chromium 3 sulfite. Well, chromium 3 I know is Cr plus 3. And sulfite, well, let's see. Sulfate is SO4 minus 2. And so sulfite is SO3 minus 2. So this is SO3 minus 2. And so I have a plus 3 here and a minus 2 there. And so I need 2 of these, parentheses, 3 of these. Write this down. Wait a minute. 3 of those. Chromium 3 sulfite. All right. Keep practicing. Nomenclature can be fun when you get the hang of it. See you in class.